Hey, what's up? Well, let's move on to point 7.4, product and division of radicals. Okay, really amazing. Okay, let's take a look at two different types of operations. Okay, so the simplest case is when you have the same index. Okay, in the multiplication of radicals. So here you are an example. Here you are an example, and this is the square root of 2 times the square root of 6. So what is the index? The index is this number, okay? It's the square root, so this is a 2, it's the number 2. This is the square root of 6, so this is number 2. We have the same index in both radicals. So it's very easy to multiply these radicals, okay? Because we put everything into the same radical and we multiply the numbers, okay, the factors. So 2 times 6 is 12. Okay, so there's nothing that we can do here. We cannot simplify, we cannot calculate the root because this is not exact, okay? So this is the solution, okay? In case you have a multiplication is quite similar, okay? So you have this, okay, well, I'm going to change the index. It's necessary that you have the same, okay, the same index. So, well, usually you will see divisions as fractions, okay? So you will have fractions. Well, so this is pretty similar, okay? So we write the same radical with the index 3. So inside the radical, I'm going to write the fraction, the division. Okay. So 6 divided by 2 is 3. So I get the third root of 6. 6 divided by 2 is 3. So the third root of 3. That's the result. Okay, second case. This is more complex, okay? We have different indexes. Why? Because in this case, this is a division. This is the fourth root, okay? And this is a square root. So that's different, okay? So what we need to do is to put both radicals with the same index. So to put this with the same index, you need to calculate the LCM of the indexes of 4 and 2. That is pretty simple because it's 4, okay? So I'm going to write in the indexes 4, okay? Well, in this case, in the numerator, the index is the same, so we don't have to change anything. So we write the same. So 2 times a squared times b. But in the denominator, the radical is different because this is the fourth root and this was the square root. So what I have to do is, okay, I'm going to divide 4 by 2. I repeat, I divide 4 divided by 2 is 2. So this number 2 is going to be the power, the exponent of the factors inside the radicals. So I'm going to raise everything, okay? Don't forget that you have to raise everything to the power of 2. So I'm going to operate this. Now I have the same index, so I can put everything into the same radical. So 2a squared b over. Okay, I have written brackets because I don't want you to forget, okay, that you have to raise the number 2 to the power of 2 and the letter a to the power of 2. So I write 2 to the power of 2 times a to the power of 2. Okay, now I have to simplify this, okay? So let's simplify. a to the power of 2 in the numerator. In the denominator, I have a to the power of 2. So I can simplify this. Okay, they are the same. And the numbers 2, I have 2 to the power of 1, 2 to the power of 2. So this is a division with powers that have the same base. So I can start subtracting from the denominator. I can do 2. Okay, 2 minus 1 is 1. So 2 to the power of 1. Do you understand this? Okay, the power is bigger in the denominator, so I can start subtracting from the biggest exponent. So 2 minus 1 is 1, so 2 to the power of 1. Okay, if you want to write the number 2 in the numerator and you want to forget this, what you have to do is, okay, 1 minus 2 is minus 1, so 2 to the power of minus 1. Okay, but if you want to leave the power with positive exponent, okay, you have to forget this last thing and you put 2 to the power of 1. Okay, this way the power is positive. Okay, the b is by itself, but by itself is alone. There is only one b. Okay, so there is no more that we can do here. We cannot simplify anything. Okay, so this is the final result. Okay, so we're going to see another example. Okay, so for example, let me see, we are going to write now another division. So 6 x to the power of 2 times 4. Okay, over square root of x 2x. Okay. Well, let me see. Okay. Well, I don't have the same index in both radicals, so I have to put everything with the same index. So the LCM between 6 and 2 is 6. So I write both radicals with index 6. The numerator doesn't change, is the same. Let me write better the 4 in front of the x, okay? It's more usual, okay? It's more usual to write the number in front of the letter. Well, here is different, so it's 6 divided by 2. Remember the operation is 6 divided by 2 is 3. So this is going to be the exponent of the radicand, the factors inside. Okay, so 2x, I put everything in brackets to the power of 3. I continue operating this. So I put all into the same radical. The numerator is the same. Okay, I have to operate this. I have to remove the bracket. So 2 to the power of 3. X to the power times x to the power of 3. Okay, now let's simplify. Well, here you are the number 4. And in the denominator, you have number 2. Well, you should factorize. You should factorize the number 4. Because if you factorize the number 4, you can simplify better, okay? So I'm going to write 2 to the power of 2 times x to the power of 2, and the denominator the same, everything with the same radical. Okay, now I'm going to simplify. So I can do, well, I have 2 here, I have 3. I can start subtracting from the largest number, the largest exponent. So I can do 3 minus 2. So 3 minus 2 is 1. So I can write 2 to the power of 1 in the denominator, and I can do exactly the same thing with the x, okay? So 3 minus 2 is 1, so 2x in the denominator. Okay, so in the numerator, there is nothing, but you cannot write 0. You cannot write 0, okay? So you have to write 1. When you have nothing, you write 1, okay, in the numerator. And let me see if we can simplify anything. It's impossible because I don't have power, so this is the final result, okay? So that's all. Bye-bye.